Automated reasoning is an area of computer science and mathematical logic dedicated to understanding different aspects of reasoning. The study of automated reasoning helps produce computer programs that allow computers to reason completely, or nearly completely, automatically. Although automated reasoning is considered a subfield of artificial intelligence, it also has connections with theoretical computer science and even philosophy. The most developed sub-areas of automated reasoning are automated theorem proving and automated proof checking. Extensive work has also been done in reasoning by analogy, induction and abduction. Other important topics include reasoning under uncertainty and non-monotonic reasoning. An important part of the uncertainty field is that of argumentation, where further constraints of minimality and consistency are applied on top of the more standard automated deduction. John Pollock's Oscar system is an example of an automated argumentation system that is more specific than being just an automated theorem prover. Tools and techniques of automated reasoning include the classical logics and calculi, fuzzy logic, Bayesian inference, reasoning with maximal entropy, and a large number of less formal ad hoc techniques. Early years. The development of formal logic played a big role in the field of automated reasoning, which itself led to the development of artificial intelligence. A formal proof is a proof in which every logical inference has been checked back to the fundamental axioms of mathematics. All the intermediate logical steps are supplied, without exception. No appeal is made to intuition, even if the translation from intuition to logic is routine. Thus, a formal proof is less intuitive, and less susceptible to logical errors. Some consider the Cornell Summer Meeting of 1957, which brought together a large number of logicians and computer scientists, as the origin of automated reasoning, or automated deduction. Others say that it began before that with the 1955 logic theorist program of Newell, Shaw and Simon, or with Martin Davis's 1954 implementation of Presburger's decision procedure. Automated reasoning, although a significant and popular area of research, went through an AI winter in the 80s and early 90s. Luckily, it got revived after that. For example, in 2005, Microsoft started using verification technology in many of their internal projects and is planning to include a logical specification and checking language in their 2012 version of Visual C. Significant contributions. Principia Mathematica was a milestone work in formal logic written by Alfred North Whitehead and Bertrand Russell. Principia Mathematica, also meaning Principles of Mathematics, was written with a purpose to derive all or some of the mathematical expressions in terms of symbolic logic. Principia Mathematica was initially published in 3 volumes in 1910, 1912 and 1913. Logic Theorist was the first ever program developed in 1956 by Alan Newell, Cliff Shaw and Herbert A. Simon to mimic human reasoning, improving theorems, and was demonstrated on 52 theorems from Chapter 2 of Principia Mathematica, proving 38 of them. In addition to proving the theorems, the program found a proof for one of the theorems that was more elegant than the one provided by Whitehead and Russell. After an unsuccessful attempt at publishing their results, Newell, Shaw, and Herbert reported in the publication in 1958, "The next advance in operation research. There are now in the world machines that think, that learn and that create. Moreover, their ability to do these things is going to increase rapidly until the range of problems they can handle will be coextensive with the range to which the human mind has been applied." Examples of formal proofs. Proof systems. Boyer-Moore theorem prover. The design of this system was influenced by John McCarthy and Woody Bledsoe. Started in 1971 at Edinburgh, Scotland, this was a fully automatic theorem prover built using pure Lisp. The main aspects of NQTHM were the use of Lisp as a working logic, the reliance on a principle of definition for total recursive functions, the extensive use of rewriting and symbolic evaluation. An induction heuristic based the failure of symbolic evaluation. Hololite written in OCaml. Hololite is designed to have a simple and clean logical foundation and an uncluttered implementation. It is essentially another proof assistant for classical higher-order logic. Coq developed in France. Coq is another automated proof assistant, which can automatically extract executable programs from specifications, as either Objective-CAML or Haskell source code. Properties, programs and proofs are formalized in the same language called the calculus of inductive constructions. Applications. Automated reasoning has been most commonly used to build automated theorem provers. In some cases, such provers have come up with new approaches to proving a theorem. Logic Theorist is a good example of this. The program came up with a proof for one of the theorems in Principia Mathematica that was more efficient than the proof provided by Whitehead and Russell. Automated reasoning programs are being applied to solve a growing number of problems in formal logic, mathematics and computer science. Logic programming, software and hardware verification, circuit design, and many others. The TPTP is a library of such problems that is updated on a regular basis. There is also a competition among automated theorem provers held regularly at the CADE conference. The problems for the competition are selected from the TPTP library.